Okay, the math professor is on the air once more, bringing truth, justice, and the American way to the education in computer-aided manufacturing. All right, so last time I talked about chapter 25, which is production planning and control. Today, we're going to go through a few problems. Uh-oh. Forgot to turn on Zoom. Mustn't miss that. All right, and what we want is this class. Oh, you know.
Enter your meeting ID followed by pound. Enter your participant ID followed by you are in the meeting now. You are the first participant. Please stand by.
Hooray for being first. All right. All right, so as promised, today we're going to work through some problems. Uh-oh, what happened? Oh, all right, there you go. All right, share screen. There we go, buck one, share. Let's open that up and let's make it large enough that students can see it. All right. One of the things that we talked about during the last lecture was MRP systems. But they gave only the sketchiest kind of explanation of how that is, how that works. And so in this class, we're going to go through that, and hopefully we'll have time to go through some other problems associated with production planning and control. All right. All right, so let's think of an object that we all understand what it is and is simple enough that doing an MRP on that is going to make sense. All right, so in this case, I am going to say that the object that we are going to make is a table. And I'm going to create a bill of materials. Oops. All right, so what do we need? We need the table top. We need legs, and we need 4 legs. we need, I'm gonna say this is an oblong table, so I need long stretchers. Stretchers are the parts that go between the legs that give the table some apparent depth. And I'm going to need short stretchers. And I'm also going to need 2 of those. Now, of course, some other stuff would go into making a table. We'll assume that we're going to make our glue blocks out of scrap wood that's lying around, but to simplify, let us assume that we have to put together a hardware kit for that. That'll have the screws, the bolts, washers, everything that's needed. Okay, and I don't want to go too deep into this because you're going to see in a moment how complicated this gets to be. All right, so all right, so what do we need? We need the period, and then we're going to go 1, 2, 3, and I'm going to stretch that out as far as we need it. And in fact, I'm going to actually go ahead and, oops, all right. What seems to be the problem here? Oh, okay. Da, 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 da. I think I'm going to need a wee bit more room. And I'm going to go ahead and do these as well. When you're alone and you're making me lonely. Uh-oh, I didn't mean to do that. All right, so we've got 15 periods. And so the item is the table. All right, under that item, we want gross requirements. And in fact, I need to shorten down requirements even more so it fits better. And let's see, then we need scheduled receipts. we need the on-hand quantity. We need the net requirements and our planned order release. Boy, that looks terrible. Let's try doing a wrap text thing. Oh, thank God, that made it just super better. I am going to make this ever so much wider. All right, so here are the basic things that we have in an MRP system. So what we're going to say is that on the 15th time period, right? We would, in an industrial setting, we would have that period would be defined. But here we're just going to say we want 50 tables in the 15th time period. Now, we would then create another one of these little tables for each of these different situations. Okay, so we've got 1, 2, 3, 4, 5. All right, so copy and paste 1, 2, 3, 4, and 5. All right, I am going to go ahead and shrink down the wee tiniest bit my width on these so that we can see the whole table at once. All right, so let us say, for the sake of argument, that on hand we have 5 tables already. Our 50 tables that are needed well, in here, we're going to have table tops. okay, our gross requirements for that are going to be actually 45. So here we have 5 and that stretches out here. All right, so our gross requirements, all right, our gross requirement is 50 tables in our 15th period. Our on-hand number of tables is 5. So our net requirements is equal to 50 minus 5. Or we have to have 45 more, right? So we want to make sure that we have a scheduled receipt of 45 tables in the 15th period. All right, so then we say, all right, let us assume that to assemble our top and all our other parts has to be started in the 13th time period, right? In other words, it takes 2 time periods to get the tables assembled. So therefore, this 45 for our net requirements comes down here . So that our gross requirement for tops is 45, right? And because I'm using Excel, I can automate that, and I can say, I know it takes 2 time periods to assemble, so I say this is equal to my time period net requirements in time 15. Now, on hand, for the sake of argument, we're going to say we have 1. Okay, so we have 1. I pull that out here. Now, how long does it take to get tops? Well, right, so we say our net requirement here is equal to 45 minus our 1, right? So we need 44 more. For the sake of argument, it also takes 2 time periods to make tops. So therefore, we have to have a planned order release of 44, right? So you can see where's a nice big, there we go. All right, so all right, so our 45 from our net requirements comes down here to our 45 right? So assembly lead time equals 2 and top manufacturing lead time equals 2. All right, so therefore, if our top manufacturing lead time, you know what, I'm going to go ahead and move that up there. Yeah, that's a ticket. Our top manufacturing lead time equals 2, that means that we need a scheduled receipt here to be equal to our net requirements for period 13. Okay, so copy, paste. Whoop. Where are you going? Right? So that carries back here. And all right, in this case, I am now let's say that we want a planned order release for these 44, but that we can make the tabletop actually in one period, right? So it won't be the same period, right? So our so that will carry from our planned order release to our scheduled receipt, and to use an old cliche, Bob's your uncle. All right. Now, what about our legs? Well, we need 4 legs. This isn't a 3-legged table or a 5-legged table. Although I have seen both of those. To get those ready in time for assembly, we're going to say that on hand we have 20. All right, so that would mean 20 goes here. And I don't know how far out we need to go. I'm just going to go like this. All right, legs to have our gross requirements, our net requirements from here, our gross requirements for legs, oh, almost forgot to do my merging. All right, so we have to have those legs in the 13th period, but we can't just take our net requirements of the 15th period. We have to multiply that by 4, because again, there are 4 legs for each. All right, so that means that our net requirements for legs equals our gross requirements minus our on-hand quantity. Now, our legs we can make in 1 period, right? Simple legs. They're just square with maybe a little bit of taper. So that means that our order release can be here, and that our scheduled release, scheduled receipt can be here. All right, so, hey, what happened? Somehow we lost all our squares here. All right, similarly, our long stretchers, we need them to arrive in 13 so everything can be assembled, right? So we need how many? Well, we need 2 for each table, where our net requirements for tables is 45. So therefore, that equals our 45 times 2. And on hand, we're going to say we have no stretchers at all, right? So we need a scheduled receipt of 90 in that period, and our on hand is 0, so therefore our net requirements are 90. All right, now long stretchers we can get in one period, so we have a planned order release of 90 in the 12th period. All right, short stretchers, we have a similar situation where we say, all right, we want them to be available in the 13th period, so it's going to be equal to our net requirements. Again, there's 2 short stretchers per, oh, right. All right, equals 45 times 2. All right, so we need 90. So that means we need, we're going to say on hand that we have 10. All right, so 10. And then we carry our 10 out here. So our net requirements is going to be equal to our gross requirements minus our on-hand inventory. We need 80, so our scheduled receipts is going to be 80. And again, we can make those in one period, so therefore we're going to say that's equal to our scheduled receipts for 13. All right, now hardware, oh, right. Hardware, on the other hand, we're going to need 45 hardware bags. We're going to say that hardware, it comes in a bag, everything is in there that's needed to make the table. Screws, bolts, nuts, washers, whatever. So, again, we're going to equal our net requirements for tables, okay, and that's times 1. We only need 1 per table. But here's the rub. On hand, we have 5. All right, so 5. We stretch that out here, but it takes 5 periods to get the bags of hardware. We actually buy them from somebody else who puts together those bags of hardware, and it takes 5 periods. So we need our net requirement is equal to our 45 minus our 5. So our scheduled receipt had better be 40. But because it needs to be 5 time periods before, our scheduled order release, 1, 2, 3, 4, 5, has to be here. In period 8. Okay? So when we do the MRP, it is an example of having to do backward scheduling in a in a system to get everything in place. Now, the difficulty with an MRP is you can put so many requirements in that that you would have to go back in time to be able to satisfy them. Obviously, that's not a possibility in the universe that we live in. Because believe me, if we could do time travel, there are some things I would go back and change. All right, maybe I wouldn't. Cause and effect, so important. All right. All right, so I'm going to label this MRP example. I'm going to go ahead and save this file. Save as Computer Aided Manufacturing and Chapter 25 Problems. Oh, wait, that actually didn't work out quite right. But damn it, I'm going forward anyway. All right, so this is a very simple example of MRP for just one order. Obviously, if we have more orders, that's going to complicate everything. Right, and this is just the MRP. For the table example, right? If we make chairs, if we make ottomans, if we make all kinds of other furniture, and we're going to use the MRP system, we're going to have to create one of these for every kind of furniture that we make. All right. So, all right, so manufacturing lead time equals 1. All right, we said that's the same for here, the same for the short stretchers, but here, no, manufacturing lead time is 5. All right. Much as I would like to beat this example to death, it seems as though it might be more useful to go on to another different type of problem. All right. So I'll create a new sheet and let's do order point inventory. All right, so let's make this larger so that you can see it. All right, so let us do problem 25.9. And what are we given? We are given that our annual demand, or D of A, equals 40,000 units. Unit cost, not unit cost though, equals $12. All right, but here, make that dollars. Make it so. All right, our holding cost rate equals 15%. Oh. All right, and I'll go ahead and make that a percentage. Setup time is equal to two hours. And our downtime cost equals $180 an hour. Wow. You don't want that down very much. All right. So, our question A, what is the economic order quantity? All right, so I need to look up the formula to make sure that I don't screw up and use the wrong formula. That would be somewhat of an embarrassing contretemps. All right, so I'm going to go ahead and insert an equation. All right, come over here, equation. Q equals EOQ equals the radical, and in the radical we need a fraction, and so it is 2 times our annual demand times our cost of setup and that is divided by our holding cost. All right, so I see you saying to yourself, well, wait a minute, we've got a holding cost rate, we've got a unit cost, we have a setup time, and we have a downtime cost, but I don't see a cost of setup or a cost of holding. Well, our cost of setup is equal to our time of setup times our downtime cost. All right, easy peasy lemon squeezy. And our cost of holding is equal to our unit cost times our holding cost rate. All right, so this is something where you have to be careful when you're thinking about this because sometimes they give you the holding cost, sometimes they give you the unit cost and the holding cost rate, and you have to calculate that. Sometimes they give you the cost of setup, and sometimes you have to calculate it from the time of setup and the downtime cost. All right, blah, blah, blah. All right, so let's figure out what is the cost of setup. Okay, well, easy peasy. It's going to be equal to our time of setup times our downtime cost. All right, so $360. Our holding cost is going to be equal to our unit cost times our holding cost rate. All right, well now, of course, it's easy to calculate what is our EOQ, economic order quantity. We're going to say that is equal to the square root, left parenthesis, of another left parenthesis, 2 times our annual demand times our cost of setup, close parenthesis, divide by our holding cost, close parenthesis. All right, so our economic order quantity is 4,000. Boy, that works out neatly, doesn't it? All right, so then we want to say B, B, what is our total inventory cost? Inventory cost. All right. Now, going back, we say our total inventory cost, and I'm going to go ahead and insert an equation again. God love me, I love having these equation things. All right, so fraction, right? And what is that fraction going to be? It is going to be the holding cost times the economic order quantity divided by 2 plus the quantity, again I put in a fraction, of I'm going to need 2, the cost of setup times annual demand, and that is divided by the economic order quantity. Okay, well, when we put it that way, that seems to make it pretty simple, because I'm going to say, all right, total inventory cost equals left parenthesis our holding cost times our economic order quantity, close parenthesis, divided by 2, plus our cost, do a left parenthesis again, our cost of setup times our annual demand, close parenthesis, divided by our EOQ, or Q. All right, so our cost, our total cost, inventory cost, then becomes 7,200. And part C is how many orders per year. Well, duh, we could do that in our head because orders per year is equal to our annual demand divided by our economic order quantity. All right, so orders per year equals our annual demand divided by our EOQ is 10. Okay, if you can't divide 40,000 by 4,000 and get 10, I'm going to be extremely surprised. All right, so that is problem, hey, what happened? All right. Well, I'm not going to fool with it. I'm just going to go ahead and write it out again. All right. And I'm going to rename it PB 25.9. All right, 25.11 sounds kind of interesting to me. And no doubt, at this point, you're saying, what kind of weirdo finds these kind of production problems interesting? Well, damn it, it's this kind of weirdo. All right, so problem 25.11. The problem is given. A part is produced in batch sizes of 2,500 pieces. The annual demand is 35,000 pieces, and piece cost is $8.50 or $8.50. Setup time to run a batch is 1.5 hours. Cost of downtime of the affected equipment is figured at $200 an hour, and annual holding cost rate is 18%. What would the annual savings be if the products were produced in the economic order quantity? Okay. So, let me see if I can read it if I put it over here. All right, so we are given that a batch equals 2,500 pieces. That our annual demand is equal to 35,000, that our unit cost equals $8.50. Uh-oh, what happened to my ribbon? Come back here, ribbon. I want to destroy the earth. Right, that my time of setup is equal to 1.5 hours, is that right? Yes. And that our cost of downtime equals $200 an hour. Uh-oh. All right. That are holding cost percent equals 18%. All right. This is really starting to be annoying. I want a persistent ribbon. Yes, thank you. All right, and what would annual savings be? All right, so we need to figure out our holding cost and our cost of setup. So our holding cost is going to be equal, as we saw last time, to our unit cost times our holding cost rate. Our cost of setup, as we saw, is going to be equal to our time of setup times the cost of the downtime for the equipment. Now we figure out what is the total cost of the inventory based on all right, and I'm just going to cheat here and steal my formula. Copy the formula and uh-oh. Copy and paste. You know, that's one thing about the equation editor that they use here that is kind of annoying, is it doesn't let you easily, there we go. It doesn't let you easily figure out. All right, so this is the total inventory cost for 2,500 and that is going to be equal to, left parenthesis, holding cost times quantity, which is in this case is our batch quantity, divided by 2, plus our left parenthesis again, our cost of setup times our annual demand, close parenthesis, divided by our batch quantity. All right, but we have to remember that we are, that's what it costs for well, let's, is that what it costs for each? Oh, okay. So, but we have to remember that it is the number of orders per year, which, as we know, is the 3,500 divided by our 2,500 times our total cost of inventory at 2,500. That's annual total inventory cost. And two. All right, there we go. Now, what would be the economic order quantity if we go ahead and use our formula? Okay, so I'm going to take a huge chance here. All right, maybe not that big a chance. All right, so what would our economic order quantity be? Ugh. it's going to be equal to the square root, left parenthesis, 2 times our annual demand times our cost of setup, right parenthesis, divide by our cost of holding, right parenthesis. And so that becomes a bit messy. So let's call that 3,705. All right, now we're going to say our total inventory cost at 3,705 equals all right, so that's going to be equal to our annual demand divided by our EOQ quantity times our total cost of inventory. And guess what? I didn't figure that out first. What an idiot. All right, so let's move that over here. All right, our total cost of inventory, left parenthesis, the holding cost times our quantity, Q, which is our EOQ, right parenthesis, divide by 2, plus our cost of setup times our annual demand, and divide that by, all right, so that's the cost, total inventory for one batch. Now, I bring this back in, and we multiply times our total inventory cost and so then we say, all right, what is our savings? That's going to be equal to the all right, I need to notate these. 7, 5. Oops, what happened there? Interesting. And so our savings is going to be equal to our annual total inventory cost for 2,500 minus annual total inventory cost for 3705. Or equal to our 85,575 minus our 53,547. The case is solved. All right, are there any questions? That's the kind of audience I like, a non-questioning one. Such being the case, I am going to call this class over. Have fun. We will meet again next Monday for a review of this class for the final, which will be the following Monday. Thank you very much. I'm wasting my sweetness on the air.